This is an introductory video of the two lectures, Part 1 and Part 2, which is based on my book, Cantor's theorem. You can download the book from this site, and I hope you read the book before watching the videos. Anyone who has some knowledge on infinity knows that the current theory of infinity, which is based on the works of Cantor, is riddled with many paradoxes, which are both counterintuitive and inconsistent. The core in the Cantor theory of infinity is that C equals 2 to the power aleph null, which is larger than aleph null, which is obtained by Cantor's diagonal argument and Cantor theorem. However, this leads to many paradoxes and counterintuitive conclusions. One of the most troubling paradoxes is that there are infinitely many sizes of infinity, and this leads to another paradox that the self should be greater than itself. Another very counterintuitive paradox is dimensionality paradox. In Euclidean or Cartesian geometry that we use every day, it is a common sense that a point, a line, a plane, and a space have a different dimension of 0, 1, 2, and 3 respectively. However, Cantor in 1878 proposed a proof that the number of points in a real number line is equal to the number of points in a plane or even I-dimensional space. This was a huge blow to our concept of dimension. And Cantor himself remarked, "I see it, but I don't believe it," in a letter to Dedekind in 1877. But I show that there are fallacies in reasoning in Cantor's diagonal argument and Cantor theorem, and will show that C is larger than 2 to the power aleph null, which is equal to aleph null. This resolves many paradoxes in the current theory of infinity. The videos are divided into two parts. Part 1 discusses paradoxes present in the current theory of infinity, and Part 2 discusses how fallacies in reasoning led to these paradoxes and will rectify these counterintuitive paradoxes. Part 1 is 80 minutes long and Part 2 is 93 minutes long. But you can move to the video which corresponds to the chapter by clicking the corresponding timestamps in the note. I hope you enjoyed the discussion, and if you find an error in my argument, please contact me by email. Thank you very much.